All right, good morning, everybody, and welcome to the second day of the Virtual SIPP Conference. You are in session 9, Parenting, Employment, and Income. And the way we're going to do things today is we're going to listen to 3 presentations and then have the 3 discussants present their opinions, and then we're going to open it up to Q&A at the end. There is a chat window where you can enter your questions throughout the presentations. And then at the end, when we have the last 15 minutes of Q&A, if you'd like to raise your hand and ask additional questions, we will do our best to get to everyone's questions and comments. So without delay, let's go to our first presenter. The paper is the gender wage gap really a family wage gap in disguise? And presenting today is going to be Young-Ju Cha.
Thank you so much for putting together this conference. It's great to just meet other researchers who are also using the SIPP data. In my opinion, it's a relatively underutilized data that have a wonderful information. So it's to certainly kind of allow us to investigate the questions that are otherwise not possible. So I'm happy to share this research. I want to acknowledge my co-authors. We are all sociologists. I'm at Indiana University. Kim and Landon are at Cornell University. Next, please. So we had this question about whether the gender wage gap is all about family wage gaps, because we often hear this in public discourse or the media, and then as well as in academic community, saying that like now the gender wage gap is all about motherhood wage penalty. And then the child is woman reach wage parity whether the child is man. Is it really true? We had that question, and then we tried to find the sort of like a solid empirical record around that, and it was actually hard to find. What it turns out, the reason why it was hard to find is because there's a huge academic division of labor. So in the one side of the literature, there's a gender wage gap literature that focuses on trends in aggregate, the gender wage gap, that focuses on the mean of the gender wage gap. And then they utilize the trends of the changes in the gender wage gap, and then focuses on what explains those changes. It's a typically kind of center around the human capital framework, the role of the education as well as work experiences, and sometimes the structural correlates of gender wage gaps, such as occupations. In the US, typically these studies use household-based data, such as Census Decennial, American Community Surveys, CPS, the current population surveys are the popular choices. And this gender wage gap literature, again, it's a center around these human capital factors and framework, and it really investigates what is the role of this family demography, like such as parenthood and marriages on the gender wage gap. That is actually answered in the separate line of the research. And next, please, which is, can you go to the next slide, please? So that's in the family wage gaps. In this line of the research, they estimate the effect of the motherhood by comparing the wages of mothers to observationally similar childless women, and to estimate the fatherhood effect on the wages, they comparing the wages of fathers to the childless men. And then similarly, the marriage effect is also estimated within this single gender framework. So they all use a single gender model. So that's why there's this disconnect between the gender wage gap and this family wage gap effect. So that's one part of the story. And then, of course, we can infer, because there's a gender differentiated effect of this parenthood or marriages on the gender wage gap, we can infer that these are going to have, this parenthood and marriage are going to have important implications on the gender wage gap, but they are rarely studied in the single analytical framework. And next, please. And the other important features about the family wage gap literature is that it really the goal of this, these studies are really establish the causal effect of marriage or parenthood. So in the US, that is actually reflected in their analytical strategies and then the data choice. So in the US, they typically use a fixed effects model, and then to do that, and then they need like a long panel data. And so in the US, they typically use NLSY 79 and 97, which is single cohort-based studies. 79 for the baby boomers and 97 for millennials. So they are like really centered around these two cohorts. And then samples often small, and then they make it even more homogeneous. They're focusing on the race, a single race group, like typically white man or white woman, and then they make additional sample exclusion as well, such as an in-school workforce are excluded from the analytical sample, as well as those people who are entering into the marriage or parenthood too early or too late. They are dropped out of the analytical sample. And then because they use a fixed effects model, and those people who are not appearing like 2 consecutive years at least are dropped out of the analytical sample as well. So typically, all these studies identify, they say that approximately 30 to 40% of the samples are, removed from the analytical sample as a result of these decisions. These decisions may be necessary to get the cleaner causal effect, but it comes at a price, which is the compromise on the generalizability. So as a result of like really restricting the sample, we lack a descriptive of pictures of family wage gaps, and then it correlates for the full labor market. Next, please. So as a result of this academic division of labor in this 2 line of the research, and then the emphasis on the causality in the family wage gap literature, there are questions that cannot be answered. So there are some holes in the literature, such as how do gender wage gaps differ between marital and parental status groups? Have childless women really reached wage parity with childless men? And second question is, what are the shares of the overall gender wage gap of each of these family status groups? Is the gender wage gap really entirely driven by parents? If not, and how much is associated with the parents group versus childless individuals? And third, how much of this total gender wage gap is attributable to family wage gaps, such as motherhood wage penalty, fatherhood wage premium, or the gender differentiated returns to marriages, and what are the relationship between these two? So these questions remain unanswered in the literature. Next question. Next slide, please. So our analytical goals are documenting the relationship between the family wage gaps and the gender wage gap, and then decomposing the aggregate gender wage gap into contributions by this, family status group, marital and the parental status groups. There's a caveat to that. I mean, we want to be like upfront about our goal is not establish the causal effect of the family wage gap on the gender wage gap. Instead, we are it's a fairly descriptive approach. In our view, previous researchers are really focusing on the causality. So there are some holes, and we are trying to fill up the gap. So our goal is to answer those, provide an analysis that are equipped to address some of those questions that are by nature analytic, descriptive. So that's our goal. And it's a US-centric approach. And then in this presentation, I'm going to show the result that pulled all the race groups. So then as a result of that, the results that I'm showing is highly skewed to these white workers. But in the paper, we are kind of like, exploring the patterns differently for the Black workers and the Hispanic workers. But given the short time, then we are going to focus on the pool sample here. Next, please. So we are using the SIPP data 2018 panel, the wave 1 data. So the reference period for that is December of 2017. SIPP data offers a lot of benefits that are not possible in other popular data sources such as NLSY or the CPS. It is SIPP offers some sort of like recent data, but pre-pandemic data. And then we are able to, include wage and salary workers from all birth cohorts, which is a huge benefit. And then unlike CPS, parents indicator, it has a cleaner parent identifier. And SIPP also has the great information about the fertility history. So you can do, even desegregate parents group by children's age and so forth. So it's a wonderful data source to investigate the parental status effect. Which is not possible in the CPS because in the CPS, non-parents actually include both those people who never had a children, but also those people who have a grown children who move out of the house. So they are all lumped up together. So it's leading to the underestimation of the parental status effect on the gender wage gap. And also another advantage of the SIPP is it includes information on the real work experience. Job tenure is provided by the SIPP, so which is important. And our analytical sample is a civilian wage and salary workers aged 18 to 69. We're trying to be inclusive here, and then with non-zero earnings. Next, please. So there are a series of 3 questions that we are trying to answer. The first one is how large or small are the gender wage gaps by marital and parental status? Next, please. So this is the slide that shows the gender wage gap by parental status. So you can see that gender wage gap is larger among parents, not surprisingly. So the gender wage gap is 23% among parents, and then the gap is 7% among childless adults, meaning that childless women earn about 93% of childless men's wages, and mothers earn about 77% of fathers' wages. So it is a lot bigger among parents compared to childless adults, but at the same time, next please. We find that these gaps actually varies substantially across by marital status, even within the parental status group. So for example, in the childless adults group, never married childless adults shows the 6% gap. But the currently married childless adults shows more than twice as that much. It's a pretty substantial 15% gap. And among parents group, the currently married parents shows 22% gap. It's the largest gap of all family status groups. But never married parents shows non-significant small 7% gap. And previously married and cohabiting parents shows a substantial gap, but it's a less lower, smaller compared to currently married parents. So it's not cleanly cut across along the line of the parenthood. It's actually there's a complex interaction between the marital status and the parental status. Next, please. And then that was based upon the raw wage gaps, and then now we are adding some wage correlates, some covariates to the model. So the model 1 is what we just saw, and the model 2 is when you're adding these human capital factors as well as the job attributes, work hours and sectors and regions and so forth. So when you're adding that, as you can see, the gap actually doesn't. Gender gaps are not explained away by adding these covariates. If any, then these gaps actually get inflated. That's because of, mainly because of the women's, women are overrepresented in the college graduates and advanced degree holders. So these, without adjusting for education, those gender gaps are actually suppressed in the unadjusted model. So after adding that, we see that the gender wage gaps gets a little bit inflated. So, for example, never married childless adults is a 6% gap. Now, in the adjusted model, it's increased to the 10%. What we actually see in terms of observing some of this size of the gap is when we are adding occupation. Can you click one more time? Yes. Then you can see there is when we are adding 510 occupations, and that's when we see some changes here. So for the never married childless adults, it's a 10% in the model 2. Excuse me. When you're adding occupations, it reduced to 6%. And for currently married childless adults, 17, and in the models that adjust for occupations is 12. Parents 23 to 17. So you can see that across all these family status groups, and it's about a third of the gap is, we can see the reduction of the gender wage gap by a third by adding the occupations. What that means is that a lot of these gender wage gap, now it's more associated with the occupational gender segregation. And then the other side of the story is that, a third of the gap is explained by those, and then the other 2/3 still remains. So, which belies some of the conservative media's, claim that it's all about occupational choice and selection into this choice. Next, please. So second question is, how much of the total gender wage gap is attributable to each marital and the parental status group? So logic here is that there are two factors. The first one is, how this contribution can be determined by the within group gender wage gap. And then the other one is a population share of each of the group. So next, please. So you can see the first column is what we just saw in the raw model, gender wage gap within the group. And the second column is it's a population share. It's a group share to the labor force. So, and the third one is a multiplication of these two, which is simply a gender wage gap within group weighted by the population share. So you can see that all the way down to married parents, you can see that 65%. So they are the largest contributor. So partly because, that's because they show the largest within group gender wage gap. We saw there's a 22% earlier. And then they are also the largest, group in the working population. They are 43% of the working population. So as a result of that, they contribute the largest amount, 65%. Never married childless adults, their gender wage gap is smaller, but they are actually 22% of the working population. So they end up, contributing quite a bit, like close to 9%. Of course, all these, when you're aggregating, you can see that parents group, 80% of the gender wage gap come from parents group, but the rest of 20% come from childless adults. So what that means is that 20%, of course, parents are the major contributor, but the 20% is also not a trivial amount. So it is a substantial portion of the gap come from the childless adults. Can you go to the next, please? The last question is really directly investigating this association between the gender wage gap and the family wage gap. So how much of the gender wage gap is associated with the gender differentiated returns to marriage and parenthood? Next, please. So we use the wage composition method. It's probably better known as a Blinder-Ohaka wage decomposition. The sociologist Evelyn Kirakawa actually published the method nearly 20 years before for that. So we are trying to give her credit. Anyway, so what this method does is decompose the gender wage gap into largely two components, endowment effects and coefficient effects. There's an interaction effect, but it's actually very negligible, so we are not going to talk about it. And in the context of this, parenthood, so gender distribution across marriage and parenthood it's pretty similar. So endowment effects doesn't affect too much into the gender wage gap. So we are going to talk about the coefficient effect, which is also theoretically what we are interested in, because we are interested in what is the wage returns to the marriage and parenthood. So it is the coefficient effect question. So this is what we are going to focus on. Next, please. So we have three models consistent to prior research, the result that we showed. So model one is the model that doesn't have any covariates, and you can see that the gender differentiated wage returns to parental status, which is motherhood wage penalty and the fatherhood wage premium effect, actually associated with 29% of the gender wage gap. So, and then for the marital status, it's about 35%. So altogether, it's a 65% in the model that doesn't adjust for any covariates. So it's a pretty substantial amount, but the 35%, there's a remaining 35%. It's not fully account for it. So when we are adding the covariates, and we can see some changes here too. Next, please. And then, so it observed some of those, marriage premium effect on the gender wage gap, but not much going on, not much change happens for the parental status effect. So it's still remaining about that 29%. What does it mean substantially? Next, please. So when we are comparing that to the more well-known education effect, this motherhood wage penalty and the fatherhood wage premium on the wage gap effect is it's large enough to sufficiently entirely offsetting the endowment effects of education. So it's 25% of the total gap. What that means is that education has an equalizing effect. So it is this motherhood wage penalty, fatherhood wage premium, those gender differentiated returns to parenthood actually wiping out entirely for the gains that we saw from the equalizing effect of the education. Next, please. And then third, when we are adding occupations, we can see some of the reduction again in the parenthood effect. So about a third of them of this effect, gender differentiated returns to parenthood, is associated with gender segregation in the occupations. It's not much happened in the marital status effect though. Next, please. Altogether, what does it say about the conclusion? So does a gender wage gap really all about the family wage gap? It's too simplistic to reduce gender wage gap in wages to mothers versus others. That's our conclusion based upon all this series of the results. We saw that there's a complex interaction across the marital status. And then also we saw that 20% of the gap comes from childless adults, which is not trivial. And then, of course, 65%, about 65% is associated with the gender differentiated returns to marriage and parenthood, but it doesn't fully account for it. The implication for that is, it's this marriage and parenthood are associated with the gender wage gap. It's definitely a major source, but it's still too premature to kind of channel all our attention to those. And then we need ongoing attention to policies that also address some kind of mechanisms and concerns that are specific to childless women and childless adults. So that's it. Thank you so much.
You're muted, Julia.
Thank you. Thank you. Now we're going to move on to the next presentation by Laura Daig, Access to Paid Leave, New Evidence from Machine Learning Classification Models.
Hi, good morning, everyone. Thanks for being here. The work that I'm going to be presenting today uses machine learning methods to examine access to paid leave in the US, and specifically we're trying to understand whether expanded access to paid leave can reach those who might benefit most from it. And this is some joint interdisciplinary work with colleagues at George Mason and Marquette. Priyanka and Catherine are both economists, and Janusz is a computer scientist, and Gaida is a student at GMU. So next slide, please. Thank you. Essentially, all workers at some point are going to experience a life event that means they'll need time off, whether that event is planned or an unplanned event. And we know that both types of events can cause costly and permanent disruptions in work and finances. There's a ton of evidence on this stuff, and I'm just citing a few select papers here from economics and from other disciplines as well. And so we also know that when events like this happen, there is evidence of kind of productivity and health externalities. Obviously, the health externalities would be of the health events, and that some evidence that workers are underinsured against these risks. And so that suggests there's a potential role for public policy to step in and address these market failures. Paid leave could be a potential policy to address this. Next slide, please. In the US, paid leave is a discretionary benefit because there is no federal paid leave policy. There are some states and localities that have paid sick leave mandates, short-term disability policies, or paid family leave policies very recently. But for the most part, workers are completely dependent on their employer's policies. And this means that a lot of workers in the US are without paid leave. There have been some recent policy efforts to expand access, including the Build Back Better that was proposed in early 2022, which included 12 weeks of federally mandated paid leave. And also, think about the recent highly public labor negotiations with railroad workers to get them paid sick leave. And in the FFCRA, at the beginning of COVID, there were special sick leave provisions as well. So none of the recent efforts beyond FFCRA, which was temporary, were successful, but it looks like this is kind of a topic with some bipartisan interest, and there certainly will be more attempts moving forward. In terms of how common access to paid leave is, we have kind of different surveys giving us different answers. If you look at the ATUS, you would see that 1 in 2 workers look like they have access to paid leave. If you look at a survey of employers, they would say more like 1 in 5 workers, pretty big discrepancy, but neither tells us about, what's going on in the workers' lives, especially with respect to health events. Next slide. So, like I said, the difficult thing here is that we don't know very much about the people who would benefit from expansions of paid leave. And by that, I mean people who experience a health event in their house or themselves, and they don't have access currently. So broadly, we know that workers in smaller firms are less likely to be offered leave, and that lower paid workers are less likely to have access. But benefits, of course, are part of a hedonic compensation package, and there may be selection into jobs. We also don't know how the health event affects the economic past of people who have paid leave versus those who don't. And we don't know these things because there's no data sets that have information on access to paid leave together with the health events that might precipitate a need for leave. Next slide. So the goal of our paper is to bring together information on access to paid leave with the occurrence of the health events to tell us something about who might most benefit from expanded access to leave. We're going to do this in 3 steps. First, we're going to use machine learning methods that are trained on the ATUS to develop a model predicting access to paid leave and apply that to individuals in the SIPP, which has information on health events like household hospitalizations and new children. Once we've identified people who have access to paid leave in the SIPP, we're going to look at differences in access between those who do and don't have a potential use for it. And then finally, we're going to focus on people who experience the health events and compare those who do and don't have access to paid leave, and look at how various economic outcomes are changing around the health event for people who do and don't have access to leave. Next slide. So in a quick preview of our results, we're going to be finding that people who experience hospitalization in their household, whether their own or someone else's, are less likely to have access to paid leave than those who don't experience hospitalizations. They're also going to be more like socioeconomically vulnerable along other dimensions. People who have a new child are more likely to have access to paid family leave than those who don't. So there may be some selection into jobs for predictable events, but it doesn't look like it's happening that way for less predictable events like hospitalizations. And finally, we're going to find that people who experience these events but don't have access to paid leave experience larger negative impacts after the event, specifically in terms of their employment and their program use. And I'll just caveat that, these are descriptive event studies. We're not at this point saying anything about like causal effects of paid leave in this paper. Next slide. So let me jump into the first part of our analysis, which is to estimate the classification model using the A2S. I'm going to give you an overview rather than going into a ton of detail about the classifications, but I'm glad to answer questions. Next slide. So machine learning, of course, is specialized at this very problem, predicting, classifying people who do and don't have things, and it's generally found to be superior to standard econometric tools for these purposes. So we're going to compare 7 different models, which I've listed here, plus we're going to estimate logistic regression, just so, you know, we get that question a lot. That's really why. So we train these models using an 80% training sample in the A2S. Each model is going to include a common set of identically coded characteristics that are in both the A2S and the SIPP. And that set of characteristics it includes kind of extensive demographic and labor characteristics of both the job and the firm you're working at. It's hard for me to jump around since I'm not clicking through the slides, but I'm glad to answer questions about that later. So once we've estimated the classification models, we're going to use several different evaluation criteria on the 20% like leave out sample that's most effective in making the predictions about who has access to paid leave in the SIPP. And so the criteria we're going to use for model selection are AUC, which I'll show you on the next slide, a correlation plot, calibration plot, to help us kind of choose which model is the best performing that we can focus on for the further analyses. Next slide. So here are going to be the results of the first criteria, which is the AUC. And this is going to show how well each of the models is predicting access to paid leave. So the way to think about these graphs, which are different types of leave, is that the more concave the lines are, the better the model is at distinguishing people who have paid leave from those who don't. So a model that like perfectly distinguishes would be a 90-degree like corner. When we're comparing the AUC across models, we consistently find that the best performers are going to be the gradient boost model and the random forest, and their AUCs are always about 0.8. Next slide. So we've kind of limited it here to the gradient boost and the random forest, and we're going to use what's called a correlation plot to choose between those. So what you're seeing is the green is people that the test data predicted to have access who do, and the red is people who are predicted not to have access who don't. And we're comparing how the random forest on the bottom axis is doing versus the gradient boost at sorting people into the groups that they properly belong into. So you can see from the side where the gradient boost sorting is summarized that the gradient boost is doing a much better job, particularly with the reds, of moving the reds who don't have access into predicting them not having access. So for this reason, we're going to choose the gradient boost as our model that we focus on for the remainder. Next slide. So now that we have a classification model that does a good job of predicting access to paid leave, we're going to use it to classify the SIPP respondents as having access to paid leave or not. So I'll talk a little bit more about that. Next slide. So first, we're going to assign predicted probabilities to SIPP respondents using the classification model. And I don't have a slide, ironically, on the SIPP exact like sampling that we took, but we're using the 2014 on panels, so all the way through 2021. We, with the exception of the 2019 panel, we leave out the 2019 panel. We identify SIPP respondents who reported household event, which specifically the events we look at are non-pregnancy related hospitalizations for either yourself or a family member separately, and the arrival of a new child within the last 6 months. we're going to compare the distribution of leave access by events, and we're going to focus then on just those who experienced the event and look at whether characteristics differ for those who did versus didn't. We're going to use a classification probability higher than 0.7 to make this binary. Next slide. So our first set of results is just showing the likelihood of access to paid leave for those who experience the event versus those who don't. So you see the kind of gray bars are the ones without the event, the transparent green outline bars are the ones with the event, and this is the distribution of access to leave. And so you can see that fewer of those who experienced a hospitalization, either their own or a family member, were likely to have access to paid leave compared to people who didn't have a hospitalization, because that distribution is shifted more to the right. And in contrast, people who had a new child were more likely to have access to paid leave than those who did not have a new child. Next slide. So we're quantifying these differences in access. This is just the average predicted probability of paid leave access based on whether they had the shock or not. And then for the analyses I show you, we're going to use leave types for each. So sick leave for people with their own hospitalization, caregiving leave for people with family member hospitalization, parental leave for people with a new child. But we also have looked at any leave, and you can see that there. So on average, for example, like 62% of people with a hospital stay were predicted to have access to any type of leave. 57% specifically sick leave, and we see that those who had their own hospital stay were 4 to 5 percentage points less likely to have access to paid leave compared to those who did not have their own hospital stay. That's how we're kind of reading this table. Those who had a new child were more likely to have access to parental leave, equally likely to have access to any leave. And then we're going to, like I said, we're going to use the specific leave types in the results. Next slide. So here we seek to better understand the characteristics of those who experience a health event. Characteristics are all measured in the first year they're observed in the SIPP. And I think slide 16 is a better summary than staring at a bunch of numbers. So let's go on to the next slide. So we find that those who are less likely to have access to paid leave have fewer years of education, more likely to be Black, are more likely to work fewer jobs with fewer hours, and have lower weekly earnings. And next slide. So slide 17, this shows some of the non-employment outcomes that we look at, and you can see this is kind of the average likelihood. We look at debt and program participation. Those without access to leave generally owe less money. They're more likely to use social programs, with the one exception of disability among those who have their own hospital stay. Next slide. So this just summarizes, so let's, next slide. So finally, we're going to use the longitudinal nature of the SIPP to look at event studies that are centered around the health events. Next slide. We're going to look at employment, financial stability, and program use before and after the event by paid leave status to see how those without paid leave differentially experience these events or shocks. Health events are measured annually, and so we're going to look at the outcomes 3 years before the shock and 3 years after the shock. This panel, because of the SIPP length, is obviously not balanced. We have looked at lots of variations of the balanced ones as well. We include an interaction between the event study indicators and having access to paid leave in the first month the respondent is observed. So we also importantly limit this sample to people who are employed in the first observed month in the SIPP. And finally, since we know that jobs that offer paid leave look different than jobs that don't, we control for job characteristics in the first observed month and demographics, since this is an unbalanced event study. Next slide. So here I'll just show you just the results of a few selected outcomes where we're seeing kind of the most consistent findings. So this is showing the difference for people with paid leave, so relative to those without. So you can see that the employment and the receipt of WIC or SNAP benefits tend to follow similar patterns before the events, but those without access to paid leave experience a decrease in employment and an increase in benefit receipt that's much larger for those who do have access. And that's what's generating the higher relative employment for those with leave, lower relative participation in WIC and SNAP for those with leave. And for debt, the pre-trends are moving in opposite directions for the two groups. And in general, there's kind of a lot of differences in trends in some of the different outcomes. So next slide. We find very similar findings after family members hospitalization qualitatively. Next slide. Similarly, after having a new child, we see a larger decrease in employment, increase in benefit receipt for those who don't have access to leave. And after a new child, we also see a larger drop in weekly income and hours that I don't show here. Next slide. So to summarize what we've just found in our work so far, we see that workers who don't have access to leave, but have an event that's precipitating a need for it, are more socioeconomically vulnerable across multiple dimensions, that workers who experience family or own health events are actually less likely to have access to leave. Among those who experience events, those without paid leave tend to be lower income workers who experience more negative impacts after the event in terms of lower employment and higher use of benefits. And all of this together, we interpret as suggesting that expanded access to leave could really help those that are most vulnerable because they're more likely to experience the hospitalizations and suffer negative consequences from them. Next slide, please. I'm going to skip talking about this, and next slide, please. I'll just leave you with this takeaway thought. So, thank you.
Thank you. Okay, moving on to our final presentation. Oh, sorry. Pinchuang An is going to present his paper, The Effect of Child Support on Labor Supply.
Thank you. Thank you for having me at the conference. This is a very good initiative, by the way. Next slide, please. Okay, so my paper estimates the labor supply responses to paying and receiving child support. To be clear, what child support is so many people are confused about what child support is. Child support is the transfer from the non-custodial parent to the custodial parent when there is a divorce or a non-marital birth. So usually, for data reasons, I'm going to only focus on the transfers from fathers to mothers, okay, but the opposite case can happen. Okay. The table on the right is an illustration of the amount of money involved in child support. So let's say we have a couple who divorced before 2017 in Illinois. Okay. If the divorce involved one kid, the father has to pay the mother 20% of his income in child support. If it's two kids, it is 28%, three kids, 32%, and so on and so forth. So as you can see, the important thing here is that the important thing for my purposes is that if the income of the father goes up, okay, automatically the amount of child support that the father has to pay also goes up. So the mechanisms for the parents are different. Okay, so for fathers who are paying child support, the effect of child support is that of a labor supply elasticity. Okay, so it is because child support is like a tax on the father's income, having to pay child support is going to reduce the labor supply of the father. Okay, then specifically, and this is the structural model is in the paper. Okay, we can map this to a Frisch elasticity of labor supply. So unfortunately for me, the SIPP panels that I'm using at least don't have information, don't have a key variable that I need to estimate the effects, the labor supply response of fathers. So for that portion, what I'm doing is to use 5 data sets, and these are very commonly used data sets as well. The PSID, the NLSY in the US, the BHPS in the UK, the HILDA in Australia, and the Swiss Household Panel in Switzerland. Okay, so I'm going to combine the estimates from these 5 data sets for power reasons, and I do find an effect for fathers. For mothers, the mechanism is different. Mothers are receiving child support. At least to a first order, the amount of child support that they receive will not depend on their income. So the response of mothers is that of an income effect. For mothers, happily for me, and this is why I'm presenting it at this conference, for mothers, we do have the key variable that I need, and so I can use these SIPP panels to estimate it. Okay, and that is important for me because I actually do need a lot of data for mothers, and I'll come to that later. Okay, next slide, please. So the empirical strategy I use in the paper is actually very simple. So I'm interested in knowing how the fathers and mothers labor supply changes when they have to pay child support, correct? So what I'm going to do is to exploit the end of child support when the eligible child is emancipated. So this emancipation age varies by location. It ranges between 16 and 21 at the different jurisdictions. That said, most places have the child emancipation age at 18. So I don't use the cross-location variation in this emancipation age much. The figure on the right illustrates empirical strategy basically. So what I'm going to do is to find a sample of fathers and mothers who have to pay child support or receive child support, and then track them over time. At some point, the child is going to hit the emancipation age, and at that point in time, I expect the child support to drop to 0, okay, or near 0. And then I'm going to see how labor supply of the parents reacts at that point. So the first question in your mind, of course, should just be that, hey, many things happen at the time that the child hits emancipation age. Okay, so when the child hits emancipation age, he or she leaves home, for example, or goes to college. And maybe going to college could be driving effects on labor supply. So to address these concerns, I do a falsification test based on non-divorced parents. So basically, these are parents who did not get divorced. They were never divorced. And then I track them over time and I see what happens when their youngest children hit emancipation age. I don't see any effect for these parents as well, either. Okay. So I'm going to examine non-custodial parents first, and then I'll look at custodial mothers. Okay, next slide, please. Okay, so in all the data sets that I have, I can construct these key variables that are necessary for the paper. The first variable that is important is an indicator of whether a parent has to pay child support or not. So this child support eligibility indicator is constructed based on marriage and fertility records. So it is specifically if the child is born before the marriage occurs, or if if I observe that a marriage breaks down, then I say that the child has to pay. Then I say that the father has to pay child support for this child to the mother. For fathers, because I don't use a SIPP, I use a long panel, correct? So I can use the residence of every child in every interview as additional information to verify whether this is true. Okay, and so I use that in a specific way. If the child actually lives with the father most of the time, I'm going to say that I made a mistake in the first step and exclude this father. Okay, so this isn't possible for the SIPP because of the short panel nature. The main outcome that I use is the annual hours worked and earnings. So these are the main outcomes I'm interested in. When I look at so I'm going to examine intensive margin separately from extensive margin. When I look at the intensive margin, it is going to be the annual hours worked, the log of the annual hours worked or log earnings. When I look at the extensive margin, it is whether these variables are positive or not. The main independent variable that I'm interested in is the child support rate. So in my regressions, I use the child support rate. This is computed as the child support amount that the father has to pay or that the mother receives, divided by the total individual income of the person. Then the last key variable that I use in my study is the age of the youngest child that is eligible for support. So this is important because it's how I construct my instrument. So this is how I construct my instrument. If the child has been emancipated, the instrument will take on a value of 1. So from emancipation age onwards, this instrument will be 1. In the year before emancipation, the instrument takes on a value of half. And then in all years before, it is 0. Okay? So the year before emancipation is the important change year, for at least for fathers, because that is the time. So in that year, the father can choose to pay or in that year, the father can choose to not pay, and then it can choose to increase his income, and then he can still get away with no penalty in the following year. Next slide, please. Okay, so like I said, I'm going to first start with looking at fathers, and then I'll go on to look at mothers. Next slide, please. Okay, so this is the first stage for the fathers data. So on the y-axis, I have the child support rate, and on the x-axis, I have the years since emancipation of the youngest eligible child. So this is the relative age of the child. Before emancipation of the child, fathers pay an average of about 7% of their income in child support. After emancipation, it is about 1%, and this drop is significant enough for me to use as in an instrumental variable strategy. Next slide, please. Okay, so this is the graphical results that I have. Okay, so I'm showing work hours on the left and earnings on the right. For work hours, what we see is that there is a nice level jump upwards at emancipation itself. For earnings, that the jump is much more gentle, but then it is still an upward shift. Okay? Both are going to be significant, as we can see in the next slide. Next slide, please. So I'm looking at the intensive margin. So when I look at the intensive margin, the dependent variable is the log of work hours or the log of earnings. The independent variable is log of 1 minus the child support rate. So this comes from a structural model. You can think of it as the negative of the child support rate. So if the child support rate goes up, the father should be working less, and that's what the negative, and so the negative switches the sign to positive. Okay, so these are directly interpretable as labor supply elasticities. For work hours, what I get is on the intensive margin, what I get is a labor supply elasticity between 0.7 to 0.9. Next slide, please. Then on the extensive margin, what I get is much smaller, so 0.3 for work hours and essentially 0 for earnings. Okay, so compared to what people have found in the literature, at least for based on general labor supply elasticities, the effect on the intensive margin is slightly larger, and therefore the extensive margin is about within the ballpark as well. Okay, so note that I can't really exclude the literature values based on my standard errors though. Next slide, please. Okay, so I'm not doing the study for fathers based on the SIPP, but at least I could talk about the US. So these are the estimates based on the US data, and I'm pulling them. Okay, so on the intensive margin, on the left, I'm showing intensive margin. On the right, I'm showing extensive margin. And then I'm showing the two US data sets I have, PSID and LSY, and then I'm pulling them in the third column. Okay. So For intensive margin, the estimates are pretty similar for the US sorry, for both the intensive margin and the extensive margin. The estimates for the US are similar to what I presented earlier based on pooled data for several data sets. For the intensive margin, the estimate is about 1 for work hours and about 0.7 for earnings. So it's slightly smaller for earnings now. Okay, for extensive margin, they're essentially 0. Next slide, please. Okay, so this is the falsification that I mentioned. So again, the idea behind the falsification is this. So I'm showing that the fathers work more when the child gets emancipated. And then I'm saying that this is because of child support. Well, they could, the easy criticism is of course that, hey, it could be because of any other thing that happens when the child gets emancipated. Okay, so the child leaves home and then many things might be happening. So to address that, I'm showing a falsification, I'm doing a falsification test based on fathers who don't have to pay child support. So these fathers did not get divorced, and what I do is I track their labor supply at the point of emancipation of their youngest children. So for work hours, I don't see any change at all. The graph is essentially flat. For earnings, there does seem to be a slight dip after emancipation of these children. Okay, that said, this dip is not statistically significant, and it is at most 1/5 of the increase that I showed earlier. Next slide, please. Okay, so now I'm going to move on to talk about mothers. Next slide, please. So I'm estimating the effect for mothers based on SIPP data. So specifically, I'm using the 1990 to 2008 SIPP data in the US. So there is actually a complication for analyzing mothers compared to the fathers, which is that the child actually lives with the mother. So for the fathers, I can take care. I can use the data to verify that to check to see how often the child lives with the father. Okay, and so I can exclude cases in which where the child actually lives with the father. For mothers, I can't do that, and this is important because hey, if the child lives with the mother, then what I'm attributing so when I attribute this to a change in the child support amount that the mother receives, it could just be because of a consumption effect. Okay, so there are potential confounders that are related to the child actually leaving home after emancipation instead of just child support itself. To address this, I'm using a regression discontinuity design strategy. It's going to be a local linear RD that's centered on a month of emancipation. So for the last bullet point, so focusing on the last bullet point, well, earlier I said that there's an income effect. In fact, it is stricter than an income effect. It is an intertemporal income effect. And the idea here is that the mother should have responded even before the emancipation of the child. The mother knows the age of the child who she's receiving child support for. And so if there were any changes that's going to happen because of changes in labor supply that's going to happen in terms of because of this emancipation of the child, well, there should be some shifting to the pre-period as well. Next slide, please. Okay, so this is the first stage of the regression discontinuity that I run. So every point on this graph here is a month relative to emancipation of the youngest eligible child of the mother. The y-axis is the dollar amounts. Okay, so this is the amount of child support that the mother is supposed to receive, and then the x-axis is the month relative to the emancipation. Is the year relative to emancipation of the youngest eligible child. Okay, so there is a typo on this slide. I'm sorry about that. The top figure is 1,900, and the bottom figure is 1,380. Okay, so there is a discrete jump at the emancipation of the child itself, and this is what I expect based on institutional knowledge of how child support actually works. Okay, so there is a drop in the amount of child support that the mother receives at the emancipation of the child itself. Okay, so and this drop is not very. This drop isn't going to be good enough. This drop is what I use for my regression discontinuity later on. Next slide, please. Okay, so talking about confounders, so on the right axis, I'm showing three potential confounders. So one is the fraction of the eligible children who are living with the mother. So earlier I said that the main worry here is that when the child is emancipated, the child leaves home, and therefore there is going to be confounding from consumption. So luckily for me, children don't leave home the month that they get children don't leave home the month that they turn 18 or something. Okay, so even though child support drops in that month, we don't see that there is a sharp drop in the number of children who are actually living with their mothers. I'm also showing two other curves, the amount of the monthly earnings of the children, and also the amount of welfare income that the mother is receiving. Okay, so these are also smooth across the cutoff. Next slide, please. So that's all in principle. Unfortunately for me, when I do the actual regression, I don't see a change in work hours or earnings. So this is actually in line with what theory should predict, like I said earlier. If there were actually any change, well, if the mother actually expected if the mother knows that there's going to be a change in the amount of child support money that they get at age 18, well, then they should be working more at the beginning already, okay, to make up for the loss in income at that point. So when I do the regression discontinuity around the emancipation of the child, I don't see any effect. Next slide, please. Okay, so these are the formal estimates, and they are all essentially zero. And then I have robustness checks based on different specifications as well. So instead of using log 1 minus the child support rate, I also use the child support amount as well. Okay, so estimates are all essentially zero. Okay, next slide, please. Sorry, next slide, please. Yeah, so this is the summary slide of the paper, essentially. So the paper looks at the labor supply effects of child support. For non-custodial fathers, I find a 0.7 to 0.9 effect on the intensive margin in terms of labor supply, and then labor supply elasticity, and then a 0.1 to 0.3, and this is sometimes insignificant on the extensive margin. For mothers, I don't see any difference from zero, and this is in line with what we should expect from theory. And that's all for my presentation. Thank you very much.
All right, thank you. All right, so next we'll move on to the three discussants for each of the papers. May I say that, but we really have two discussants. One person is discussing two papers. Sorry. Okay, so to discuss the first paper is the gender wage gap, really a family wage gap in disguise. We have Carl Sanders who's going to discuss that paper.
Hi, I hope you can hear me okay. Sorry, I don't have a functioning camera. I am on the road. So first off, I'm discussing this the gender wage gap, really family wage gap in disguise. Next slide. All right, so just I'm just going to give, I guess the way I do discussing is I usually give my own summary of the paper on, first, which might not be the exact perspective of the author, but it's at least how I think about it. So we've known for a long time that it's too simple to think of the gender wage gap as just, you know, 20 cents or 30 cents on the dollar, depending on when it is. 20 cents or 30 cents on the dollar for every possible woman in every possible job. And so there's been a lot of interest in trying to understand for exactly how big the gap is for different sets of characteristics. So occupation was mentioned significantly in the paper, and I think that's one I'm just very interested in personally, and so I put it here. If you look, you can run the usual wage gap regressions within occupation, something I've had students do before, and you still get pretty big numbers for most occupations, even ones that have differing levels of actual women and men working in them. It was mentioned earlier, I think in the chat, that this is true across different firm sizes as well, that typically I think it's estimated that, is it bigger? I haven't seen this one in a long time. But at least there are differences. I can't remember which direction it goes of gender wage gap across different size firms and different levels of education, things like that. So this paper is focused specifically on parent relationship and child raising. I think implicitly and maybe explicitly, depending on where it is in the writing, we want to, the sort of goal of these is worth keeping in mind because you could always just be chopping the data an arbitrary number of ways. We're interested in the causal side, typically. At least that's what I'm interested in when I think about this literature is what sorts of policies can we put in place to eliminate any undesirable or specifically discriminatory parts of the gender wage gap. And I guess the descriptive part, the flip side of that is if we discover that it's really just a descriptive phenomenon and that there's no sort of underlying discriminatory framework or discriminatory behavior underlying it, we might not want to address it with policy. Again, this paper finds a large role for family status and decomposition of wage gap, which is a very interesting result and something again worth diving into, which there's a lot of work done in this paper to understand the different aspects of that. Next slide. For strengths, it's just nice to have a paper that gives sort of a full accounting of relationships that have been very cursorily discussed. There have been papers before that mentioned, oh, here there's for this particular subgroup of unmarried women with no children or something like that. But this gives a very full understanding of when you read the paper of what sorts of groups there are wage gaps and what sort of groups there aren't, both conditionally on, or both unconditionally and conditionally on all of the other sort of common factors. The decomposition done here does help us understand the overall role of parental relationships. I think it was unmarried, childless was mentioned as sort of the second biggest, but the dominant force here is currently married. I think I don't put it here, but I believe it's with children. I think it's a typo. Currently married with children, huge wage gap, 25%, 25.5%, and is a huge percentage of the overall sample as well, right? So if you think of where the wage gap is sort of focused, not 100% of the wage gap shows up here, but it's very focused on this group. This also to me suggests, almost as a follow-up point, but it's nice to get sort of future directions from these sorts of papers, is that understanding what's going on inside marriage in a more sophisticated, for lack of a better word, way would be useful. In particular, is it selection into marriage from the front end, or is it sort of then maybe specialization within a marriage, or other sorts of negotiating within a marriage or something like that? Negotiating over who gets the job they want and who gets the job they don't want in the case of like moves or things like this, and that could be causing a problem. Next slide. There's sort of a structural problem with, I don't want to mean papers like this. There's an intrinsic problem with these sort of breakdown by demographic group papers, which is that at some point you have to decide when to stop because you're just going to keep chopping and chopping and chopping until there are huge numbers of categories. You could always be concerned, what if within the 18 to 24 category, it's just people who are 18 to 20, and I need to divide that into 3 groups. So and unless you're in these monstrous administrative data sets that don't have the specificity that you need for a lot of these sorts of analyses, you get sample size breakdowns. I just picked, I think, the 2 smallest sample sizes in this paper that I saw for subcategories are 18 and 19. You could imagine, so one more chop, if we wanted to split this by education, it would be completely infeasible for a huge number of groups. Okay, and that's just, I mean, do I have a solution for that? I wish. But it's worth noting is trying to understand, maybe think about future papers, trying to plan out what should we do once we run out of subcategories, once we run out of samples for subcategories. The second thing that I think could be interesting is thinking about the location of the children. So residency status. I mean, the last presentation was about child support, which is relevant here. Residency status, child support, these sorts of things, especially for those who were previously married and have children. That's really presumably going to make a difference. It might very much constrain where people can live, the sorts of jobs they can take if they've divorced and the child has to, for instance, they both have to be in the same city as the child, is one example, or something like that, so that they can split custody. And so And I think in a previous version of these slides, I might have had something about number of children, which I think I was also thinking here that like how many kids are in your household, how many kids are in the father's household in those cases of separation. Okay, and then third, there's just with actually of selection in a marriage, there is longitudinal data, a little more difficult than SIP, but that because it's a shorter panel in some cases. But in longer, you could link the SIP potentially with longer administrative data panels or other panels that would have information on what people were like before getting married and after getting married and see what happened to the jobs of those two individuals. Well, the future spouses, I should say. Okay, next slide. Okay, so here I've mentioned the point that I thankfully didn't forget. For future directions, I think it's worth also thinking about children's age. Again, kind of related to the last paper, as the children get older and closer to freedom and leaving the household, what changes for parents' job choices and their relative wages, and then family size generally. There might be a bias. There might, for instance, be less of a gender wage gap if both parents are working because they need to make more money versus maybe one spouse is more free to take a job that pays less but is more fun or something, or is more flexible. There's been a lot of emphasis on flexibility, where there might be a lower wage job, but you also can have more time off for more flexible schedules. And a much more bigger picture issue, I would say then, is trying to think about what is going on behind relationship status in a more continuous measure. So, for instance, is all that matters about relationship status how much time you have to spend with the child? That would be kind of nice because it's a number between 0 and 172 hours in a week or whatever there is. And then that way you wouldn't have to continue to chop. You could say, okay, for these people who are divorced spend this number of hours a week with the child. This couple is married, spends this number of hours a week with the child, or this individual spends this number a week. And you wouldn't run into quite so many sample size issues. That's a little more speculative, but I just thought it was something worth potentially thinking about in the future. But overall, a really interesting paper, and I enjoyed reading it. Thank you very much.
All right, thank you, Carl. Our next discussant is Shalise, and she's discussing the paper Access to Paid Leave, New Evidence from Machine Learning Classification Models.
Thank you, Julia. Yes, so as Julia mentioned, I'm discussing the paper Laura presented a couple of presentations ago today. So next slide, please. So as Laura mentioned, there are two questions in the paper that they're trying to address. They want to figure out if people who need the paid leave the most actually have access to paid leave, and then they want to compare the characteristics and economic stability of workers with and without paid leave in their paper. Next slide, please. But they have a data limitation. There is no data set that has both information on paid leave and family health exigencies. The American Time Use Survey has a leave module with paid leave information, but doesn't have any information on family health exigencies. On the other hand, the Survey of Income Program Participation has information on family health exigencies, but only asks about paid leave from parents who took leave before the birth of their child, and not about paid leave in general. Next slide, please. So the authors have a creative solution. Using machine learning, they will train classification models on the American Time Use Survey to predict access to paid leave through an employer in the Survey of Income Program Participation. So then they will have to restrict their analysis to a set of variables that are common both in the American Time Use Survey and the Survey of Income Program Participation, and they also need to align the timing of the two surveys. Next slide, please. So one comment that I have for the authors here is that the SIP doesn't ask about paid leave in general, but there is a question about reasons for workers to take time away without pay. And I'm just listing some of the reasons here. And some of those reasons in the 2021 panel that are important and relevant to your work is having health concerns, injury, illness, having some of those family obligations that you mentioned, and of course, pregnancy and parental leave. So having leave with no paid doesn't necessarily mean that you don't have access to paid leave. But I think it is a good indicator. It could also mean that people had exceeded the number of days and times that they had access to paid leave and they had to take leave without pay. But I think this is a good variable that you can use to validate and look at the consistencies of the predictions using your machine learning model and the survey data that we have. Next slide, please. Also, it wasn't clear to me how you incorporated the longitudinal aspect of the SIPP into your model. I think people that stay in the same job from one wave to another should have access to the same paid leave before, so their access to paid leave shouldn't really change if they stay in the same job from one wave to another. And we have a job ID that is consistent across waves that you can use to identify people who've stayed in the same job. And this is another robustness check and validation test for your data and predictions to see if your predictions are consistent for people who stay in the same job across the waves in the panels that you use. Next slide, please. So the authors use a machine learning model and they use 7 different models. Some of them are parametric, some of them are non-parametric. So my comment here to the authors is that I think you should hold your reader's hand through your method sections a little bit more. For example, it wasn't clear to me why you consider both parametric models and non-parametric models. They both have their strengths and weaknesses, and given your data or the questions that you ask, one might be more appropriate than the other. For example, it's well known that non-parametric models perform better when you have large data sets, a lot of observations, and you don't have a prior knowledge of the data, so you don't want to make any functional form assumptions about the relationship between your input variables and output variables. So I wasn't sure. I mean, you look at 7 different models, and I wasn't sure why these 7 specifically. So next slide, please. So for example, in your parametric models, like parametric models make an assumption about the relationship between your input and dependent variables. It could be linear. You could assume that there is a logistic regression, and so the functional relationship between input and dependent variables follows a sigmoid function, and you could have binomial, multinomial, ordinal logistic regressions, and this would be the functional form that I think traditional economists would use for analyzing your question in the research paper. But you also introduce lasso and ridge and elastic net, which are regularized regressions. They introduce a cost function into your regression function to reduce overfitting and collinearity, and they do this by shrinking the coefficients on the variables that are less important towards 0. But they each do this differently, so that the way that they do that shrinkage in lasso, ridge, and elastic net are a little bit different. And so I think a discussion about why ex ante is not clear which of those shrinkage methods would be more appropriate here is also important. Like, why do you have to do all 3 of them? So I think a little bit of discussion about that is helpful. Next slide, please. And that's also true for your non-parametric model. So if you use decision trees, we also use ensemble methods, including random forest and gradient boosting. They're both ensemble methods are both a collection of decision trees, but there are differences between random forest and gradient boosting, and that's how they build those trees in their ensemble method, right? Random forest builds individual trees in the model independently of each other, whereas in gradient boosting, those decision trees are added additively to the model. And so again, there are differences in these models that weren't discussed, and I think that you should guide the reader to expect the performance that you see at the end, because it's not that it's just not clear. Maybe it is true, but I don't think so. Like from the literature that I followed, it's always very clear that gradient boosting performs better in these cases for the most part. So I think a little bit of discussion on that would be helpful. Next slide, please. The authors have a set of different evaluation metrics that is great. They use the area under the curve, the concordance statistics, they use calibration and distribution of outputs, they use a correlation plot, they even use the local interpretable model agnostic explanations to evaluate all of the 7 models that they have, and they finally choose the gradient boosting as the best performing model. Next slide, please. As Laura said, they do predict a continuous probability of access to paid leave, and they find that individuals with hospitalization in their households are less likely to have access to paid leave. And they also find that people that have access to paid leave, that don't have access to paid leave, are less likely to be employed, and they're more likely to receive WIC and SNAP benefits. So there are the people who need potentially need having access to paid leave the most. Next slide, please. So I will just conclude with a couple of last comments to the authors. The basic splitting of your data 80-20 in training and test data. But there were no discussion of whether you ensure to having the same share of people with access to the paid leave in both your training and test data. There was no mention of using K-fold cross-validation to making sure that you don't overfit or overtrain your data. It wasn't clear to me how you selected the variables that were common in both in the American Time Use Survey and the SIPP. Did you use literature, your expertise as economists and computer scientists, or did you use machine learning to select those variables? You also did mention doing hyperparameter tuning, but again, there was no discussion of which hyperparameters you optimized. With that, thank you so much. It was a wonderful paper, though. I really enjoyed reading it, and I hope that I can see another presentation by you on this work. Thank you.
All right, thank you, Shalise. And we have one more discussant, Carl, again, discussing the effect of child support on labor supply.
All right, hello, it's me again. This is my comments on this child support and labor supply paper. Next slide. All right, so just to summarize a little bit more, and this wasn't actually covered quite as much in the talk, but the question at hand for the majority of the paper, and I realize a lot of this paper wasn't SIPP specific, and maybe some of my verbal comments, I'll talk more about the SIPP stuff more. So the Frisch elasticity is the effect of changing the wage on labor supply holding fixed the marginal value of wealth. So what easier way to think about this is that I'm going to change someone's wage, but I'm going to hold their lifetime budget constraint the same. So I'm not making them poorer in the sort of income effect way, but I'm not going to make them poorer across time. I'm not compensating them directly necessarily today, but someday, for instance, I might compensate them again. So this is particularly relevant for sets of policies like in macro, where if I'm taxing someone right now, or I'm just subsidizing them right now, someday that has to be repaid or retaxed because of government budget constraints. So I can't just subsidize someone forever because I'll run out of money. So they're going to know that later that these taxes are going to have to be repaid. And with an object this complicated, it's just difficult to get a credible estimate because it's sort of intrinsic to a dynamic setting where it's even if you can have a nice little experiment in one period, but if it changes things in the future, it's no longer a clean experiment because this is a dynamic object we're interested in. It's something that's forward-looking, and so it's hard to find a lot of experiments that are going to do what we want. And this paper, of course, uses the fact that child support is a known to everyone, including the people involved in the situation cliff around the time of emancipation. So this is the contribution as an instrument, and it's a very nice one. It works, I think. It's mostly very effective with some caveats I'll get into later. right, next slide. Yeah, so the first thing, I mean, I think the most obvious strength of the paper is this cliff. It's just a really solid first stage. Solid both because you can see it does a lot in the usual analyses, and just the usual analyses, and the first stage is very strong in terms of F values and things like that. But it just, an even plausibility of why it should be a good first stage is nice. We can all pretty much believe people know about child support. People know child support ends in emancipation. There are no secrets in this policy from anyone involved. And so it just works really effectively in that. Moreover, it's a nice cliff. Like it's a very strong cliff because it isn't phased out as they get closer to emancipation or anything like that. The other strength that I really, really like, and it's hard for me to emphasize how much I like this, is the use of multiple data sets. I think this is something that needs to be done as much as possible, basically. It's often the case. And I should mention, actually, that Laura's paper was another example of this as well, that multiple data sets are just going to have a lot of information that one data set doesn't. And even if there's just tiny weakness in your existing data set, that can often have kind of severe issues for making sure your results are right, and robustness can really be improved by just pulling an entire new data set out of somewhere else and looking through it and seeing what you can get there. There's also, I mean, another strength is just this fact that that the kids are typically with the moms, and specifically from the SIPP when they are with the moms. My understanding is even if you didn't know that, the vast majority of children are with the mothers in these sorts of cases, if the dads are non-custodial. So with the SIPP data, you're able to know where the children are, that I will say is something you wouldn't necessarily know from huge administrative data sets. You're not going to get necessarily good records on exactly where the kids are at any point. Even from tax records, you're really only going to find out where they spent the majority of their time. Usually their rule is 6 months plus. They're supposed to, that's supposed to be the one claiming them as a dependent, but you wouldn't know on sort of week-to-week basis or exactly how much the time is split. So this is just another example where I can a little bit say, here the SIPP or something like the SIPP, a survey-based data set, would be superior in this aspect to a lot of larger administrative data sets where you wouldn't know that. And then another strength is just the results are very interesting and seem to feel okay, plausibility-wise, and there's been good robustness work done to find these plausible facial elasticities, do good robustness work on it. There is a negligible income effect on the mothers, which I'll talk about probably also in the weaknesses section. So it's a strength to be able to find it. I'm not like it's a cool kind of side product of the project, but I don't necessarily think that's, if we go to the next slide, something that I am 100% sure on yet. All right, so next slide. Despite combining the data sets being great, which I still think is great, it is a little bit frustrating, I think, from the author's perspective, for them to have to be from different countries. So, for instance, Hilda in Australia versus NLSY in the US. The institutional support system, or institutional frameworks, particularly not child support as in parental child support, but the government supporting children and families is pretty different across these countries. And to the extent that those differences aren't modeled, I think can make it difficult to understand the frameworks. So for example, we don't know exactly how much money the government takes away from a family once a kid leaves the house on taxes. Like that might make even some of the falsification checks a little less clear, because a non-divorced family, the government may take a bunch of money, whereas if you were divorced, the government might only be taking money from the other party and not you strictly. So it makes it hard to know exactly what's going on if the institutional details are all very different. And that's almost sort of an issue with the overall framework, a very similar issue with what I'm calling here the McCurdy style models, which are these written as dynamics, kind of more structural models, but can be implemented in IV frameworks, like more standard looking IV frameworks, and can have the parameters directly interpreted of those IV frameworks as labor supply elasticities. Which is like, they kind of hit a point where if things get too complicated, they no longer work. Like with certain types of kinks or shifters and fixed costs, it no longer is the case that I can map the results from this, full model into just a couple of two-stage IV regression or anything like that. And that's sort of an issue too with the different cross-country institutions. If some institutions have kinks or holes or fixed costs or shifters that other ones don't have, it's going to be impossible to capture that consistently using the same estimation method across every country. Oh, sorry, there you go. I mean, very personal preference on this point, but I'm a structural person, and I think that some more structural modeling could be helpful, ones that don't necessarily have to reduce to these IV methods, at least as robustness checks. Like for instance, you could think you could maybe include a couple of details of the individual country's policies, and at least use, as structurally estimate those kind of within each country using those policies, then checking to see that your results are all consistent with what you think they should be, something like that. Maybe that specific thing is too much work for this part of the project, but I think the structural modeling part would help a lot with the last point on the slide, which is just the mothers section, which is, I don't think these, again, McCurdy style methods work particularly well with what's going on in the mothers part, where we talk about, well, the kid is leaving home, means there's an income effect. Because the natural one to think about is that at the same time the kid leaves home, we know the consumption equivalence bundle, or the consumption equivalent amounts for the mother are going to be changing. And you can see this in the paper where there was a kind of formal model leading to the IV results for the fathers, but I don't think that model works for the mothers. I might be wrong on this, but I don't believe it works exactly the same for the mothers. And so there isn't really one for the moms. We just run the regressions, or the paper just runs the kind of similar regressions without quite as much formal justification. Similarly, the problem is also here, of course, the kid can decide whether to leave home or not, and the father can decide or not whether to give the child money if they leave home, or if they don't leave home, not give them money, right? Things like this, which just end up making this problem a lot more complicated. So without sort of a clean experiment, quite as clean of an experiment where a child is just booted out of the house at a certain age, it's harder to interpret these results. Instead, what we're getting is this total regime change effect, which is what happens after emancipation. And it's hard to make sure that that's only the income effect and not a bunch of other effects at the same time. Like, for instance, that it's not a wage effect on the mother because now she's free to move somewhere where she could get a higher wage job or something like this, right? Okay, next slide. Another thing I think that might make it a little more interesting, and this is more of a direction for future research than a problem with this specific paper, which isn't interested in exactly this idea, is thinking about a specific policy. Not all policies have Frisch elasticity as the policy relevant value at hand. With the sorts of work you've been doing, you could take these estimates, not just the Frisch elasticity, but all the estimates you get, and think a little bit about how should we maybe structure child support. Is this an undesirable cliff or not? We tend to think cliffs are undesirable in a lot of settings. Not clear that this sort of cliff is undesirable, right? Where it, at a certain age, it's tried, obviously, naturally timed to be with the child leaving home. That's sort of the goal, is that emancipation time is timed around that. So maybe it's a desirable cliff in this sort of dynamic setting, and you could use your modeling and your results to think a little bit about that. For instance, should we phase out child support instead of have a cliff? And I do think that maybe this, again, this is more of a different paper sort of topic, but even in this paper, you might want to think a little bit more about the mother's problem and the joint problem faced by the mother plus child household, if that's who we're thinking about. Because I think it's just a really interesting topic to a lot of people these days, especially, about the timing of a child leaving home is something that needs to be thought about a bit more in the literature. That in a lot of these family models, the sort of dissolution of the child leaving the household. Now that kids are much more likely to stay in the household till they're 30, or 35, or however old. It's more important to start thinking about what's going to push them out or keep them in. What sorts of policies are having effects on this? Okay, so anyway, those are just some comments, but I really enjoyed it, and I really enjoyed the presentation too, and thanks a lot.
All right, thank you, Carl. We can open it up to question and answers now for the remaining about 11 minutes. There was, so far, I see one question or comment in the chat, and it's from Shalise, and it's a question for Youngju. Literature also shows that sorting across firms by gender explains some of the gender wage gap. Did you control for employer size? Explicitly, SIPP has a variable that measures employee size.
Should I answer to the
Yeah,
question?
you can answer. Yeah.
Yeah. Thank you so much for the question. Yeah, so it's it's amazing that you can just pull out the variable name and on the spot. So it's so impressive. Yeah. So the recent research actually, like I think that one article in PNAS and found that they actually had a firm level establishment level data, and the gender wage gap still remains within the firm within after controlling all those like firm level. So it is certainly those explain a little bit, but the large portion of the gender gap remains. But yeah, you're right. I think that there's we talk about the occupational segregation, but there's also like you said, organizational level, like a firm level segregation. So we could look into that by the size, which correlates with the kind of gender segregation story. So thank you so much, but we haven't looked at it.
All right, if anybody else has any questions or comments, you can raise your hand and we can unmute you, or you can ask the question or give the comment in the chat as well. All right, Madi, you have a comment? I don't know how to, am I allowed to unmute people, or I'm sorry, I forget.
Hi, Madi. You may have just seen a note that you can unmute yourself if you like. And if not, I will try to send that message again. Down towards the bottom of your screen. There you go.
Thank you so much for the invitation. And this is a great 2 days. I listened to a wonderful papers written by smart people whose the data that we collect for so many years past. Special thanks goes to all Seaside and particularly Shelley's. I definitely enjoy all these presentations, but I do have one comment. I did notice that most of the analysts use modeling to analyze data, like regression, logistic regression, propensity, and so on. But I didn't see clearly how they use the sample weights in their model. Some said yesterday, I believe, their paper only for description. I will say, no matter what you use the data for, description or cause and effect, understanding the relationships, all these good reasons to use those modeling, so you need to use the sample weight that census provide, and specifically DSMD provide those on their page. I believe, and everybody knows, that SIPP is not a self-weighting survey or sample. It is, we oversample the low income stratum, so it will be a lot better. Even sometimes I hear some people say, I run it with weight, I run my model with weight, I run it again without weight, and there is no difference. Even if that is true, which I don't believe it, but anyway, assume it's true, still you need to create your weight, you need to create the weight in your model, whether as an independent variable or as a command for weight to be used. I am so pleased to hear all these beautiful papers and their results and the way they use the SIPP. I would like, if they're gonna really create some workshops to include the SMD talking about how to use the weights in their models. Thank you so much, and waiting to listen to the listening session. Thank you again. I'm just gonna,
Thank you. You make a very good point. It's always good to use the weights that we supply when you're running models on SIP data. It makes it more nationally representative. So no one really mentioned it, whether they were or were not using them in their papers today, but it's something important to remember. All right, does anybody else have a question or a comment?
I might comment on Mari's
Okay.
statement about the weights. So this was something really interesting to us that I, of course, didn't have time to talk about in the talk because of, we're using 2 different surveys that have different sample frames and different ways of, translating those sample frames into nationally representative weights, and we had to think about that pretty carefully when we were building our models and thinking about, okay, do we want to build them on weighted data? Do we want to, all of these kinds of things? And so in the results that I showed you today, the ML side of things, I think, is unweighted. When we use the SIP, we weight them for using the SIP weights to be nationally representative. I think because so many of our, it did make a big difference in sort of how the overlap looked from the SIP to the ATUS, and how we think about like how well the ATUS results could translate into the SIP. And so I just want to, I guess, agree that it's a really important design consideration, and definitely if you want to be presenting results, should be using the weights. So thank you, Madi, for that comment.
Okay, I can give it another minute or two, or and then we can end 1 or 2 minutes early for people to get to the next sessions. Yes, you can say one more thing. Does Madi still have the ability to unmute himself?
Madi, you should be able to unmute yourself now.
thank you so much. I forgot one thing because I just heard it, that some of the analysts dropped SIP 2019. I think Census Bureau dropped, we don't say even drop, we did not continue with the 2019 for Wave 2 Plus. So I don't know when you drop the 2019, you are dropping some data that were weighted for that year. So I don't know how they use the weight when they drop. I believe, and I will continue to say that for the 25 years ago, I continue to say consult with us. Consult with DSMD because they are the one creating sample design model. So consult with them how to use the weight. I don't know if I made my point good. Thank you so much for giving me the opportunity.
Okay, I think he's just talking about the concern of the 2019 panel.
Yeah.
And when you drop it, what happens with
if anyone has advice about exactly what we should be doing, I definitely want to hear that. So what we do in practice is our understanding of the SIP documentation is that the 2019 panel itself probably was not best to be using it, but that the 2019 data from other panels was still okay. And so that's kind of what we followed in our analysis. But I definitely, we are open to hearing other advice.
So Laura, that's correct. So the data from the 2019, the cases that were wave 1 in 2019 are the ones that needed to be dropped. And that's because of some issues with data collection.
Awesome, thanks. And the weights we should be using are still for the 2018 panel, for example, the 2019 data are the same weights we would otherwise use.
Correct.
Awesome, thank you.
Yeah, and refer back to the user's guide. There's a nice write-up there, a technical note about what happened with the 2019 panel.
Yeah, and I think that'll be a good result from this conference, is that we can all see each other's faces and maybe feel a little more comfortable to, send census an email if you have SIP questions. The analysts here all, we're happy to answer questions that you have, or if you find confusion when you are reading the user guide. Part of our job is customer service, so feel free to reach out and ask us questions if you run into them when you're dealing with data. All right, so I guess we are out of time. So thank you everybody for attending session 9. I hope everyone learned something and can take something positive away. All right, I hope everybody has a great rest of their day. Thank you.